This is an example of function properties, and this will be example number 2. So we're going to do similarly like we did in example 1, we're going to find all of the properties of this function. So here we have absolute value of the quantity x minus 5 and then plus 3. I've graphed this function so you can see a picture of it. So we're going to start again with domain. Remember, with domain, we're going to ask ourselves 3 questions algebraically. Is there a variable in the denominator of a fraction? No. Is there a variable under an even radical? No. Is there a variable after log or natural log? No. So here all I'm going to do is say that my domain is all real numbers, negative infinity to positive infinity. I can see that on the graph here too. It's going left forever, and then we have a continuous graph that's also going to the right forever. To find my range, I'm going to look at the graph. My range up here is to show a minimum point right here. Remember, on your calculator, if you want to use your calculator to find your minimum, we can do second trace minimum. And we need to do left bound, right bound. So I'm going to get a left bound there. Going a little further, get a right bound. When it says guess, you really don't have to move your cursor. You can just press enter. So here we're seeing that our minimum point is the 0.53. So that means my y values start at a value of 3 and go up forever. So then my range is going to be from 3 to positive infinity. This is a continuous graph. We can trace it without lifting up our pencil. So we can just say this is continuous over its whole domain. So it's continuous from negative infinity to positive infinity. If I start tracing this graph right now, we are decreasing until we get down to this point right here. And then after that, we would be increasing. So I'm going to say this graph is decreasing. Remember, with increasing and decreasing, we give those values in ranges of x values. So this is decreasing from forever to the left, negative infinity, until this point right here, which is 5. So to 5, and I'm going to put the square bracket on that to include the 5. After that, we are then increasing. So we're increasing starting at the 5 and then going forever to the right to infinity. Again, I'm going to include the 5 because that point exists. Do I have any extrema on this point? So this 5, 3 point is a minimum, and it's an absolute minimum. So I have a min at 5, 3. This graph is bounded below by that minimum point. So the graph is bounded below. This graph is neither even nor odd again. It is symmetric about the line going through the vertical line going through the minimum, but that's not considered even or odd. We have no asymptotes on this graph, and my end behavior on both the left and the right, my limits are approaching positive infinity, so my end behavior is unbounded. So remember, there's a difference between the boundedness of the graph. This graph is bounded below by that minimum point, but the end behavior is unbounded because on the right and the left, the graph is going up to positive infinity on both sides.